5. Is that positive 5 or negative 5? Positive 5. So we put our red meter lead here, and we put our black meter lead here, and we look for 5 volts.
Not ohms.
Do you understand? No, I said, where would you check for voltage?
Yeah, no.
It doesn't matter which way I put the leads when I do an ohms test. No. So in other words, if I wanted to check the resistance value of this sensor, I unplug it from the main board, refrigerator power's off, and I stick my 2 meter leads on the same 9 and 10, but on the wires, not on the board. And I check resistance value of the sensor. The resistance value doesn't matter whether it's AC or DC. When you check resistance with a meter, you're already using a battery in your meter, which is DC voltage, and that DC voltage is going to flow through it. The only time it matters when you are putting your meter leads is if you have a triac or a diode or something where resistance value matters, polarity. But for most components like sensors, it doesn't matter which one's the black or red if you're going to do ohms test. If you're going to do a voltage test, it matters. And you have to look for that plus or the ground to know whether your black is your ground and red is your plus. You must put those wires on the meter properly. Your meter's going to have 2 holes where those black and red wires go. Sometimes they're color coded. Sometimes it says common on one of them, which is the ground. And the other one says ohms, volts, whatever. That's the positive, the red one.
What's gonna happen if you put it wrong, like?
If you put it wrong,
Yeah.
for ohms it doesn't matter. But if you reverse the wires for voltage on a DC digital meter, if you put the wires backwards, most of them, as long as the voltage isn't too high, it'll just say instead of +5, it'll say -5. It'll go the opposite way. But if it's an analog meter, where the needle moves, instead of the needle going up, the needle will go backwards, and if it's a high enough voltage, it'll bend and damage your needle.
Oh.
Yeah.
So you need to have polarity right, especially on an analog meter. And I love analog, so yes.
So how do you know the resistance value of the thermistor?
I don't know, we just guess.
That's the problem. Sometimes you don't know, like.
Oh, we don't know the resistance values, right?
Nope.
So we need to go here to the tech data sheets. Let's see here with the tech data sheets. Let me see if I can find it on here for you. Here we got some tests too. We're going to talk about those tests in a minute. It should have the resistance values based on the temperature on these 2 sheets. I'm trying to find them. It doesn't have them right here on the chart. But we have a tech data sheet. I don't have that open right now. Let me see here. This is the ice maker. Let's see if they have the temperature resistance values. I haven't gone through this stuff yet.
Is that this?
That's for the ice maker.
Yeah.
Alright, I'll find you the resistance values. How do you know? Let's go back to here for a second. So let's say we have open or shorted thermistor in the unit, right? So we want to know what the resistance value is. Well, we also want to go into activation and deactivation of components. Let me go to the next page here. Here we go. System diagnostic mode. So inside the refrigerator, they have a diagnostic mode. It's good to put a meter on it, but diagnostic mode is to help you eliminate or get down to the components that failed. If we thought we had an open sensor or something, let's look over here and let's take a look at the instructions. To activate it, you press the up and down arrow for 10 seconds simultaneously. Okay? To deactivate it, press up for 10 seconds and diagnostic mode will automatically deactivate. So, what up and down arrow are we supposed to press?
Here on the display.
Huh?
Here on the display.
Well, you know what? We got more than one up and down arrow in there, right?
Where are they?
We have
We have plus and
an
minus.
up and down here, and we have an up and down here. So which
The
ones
left-
do we
the left
press?
side.
When
The
you
freezer
open
is
it,
down close to the freezer.
One in the freezer?
One close to
The
the
left side.
refrigerator.
Suzy,
Go ahead, I'm listening.
if you look at the upper one, it has the arrow that's looking up. But the second one, it has plus and minus. Press plus.
I know this is to advance, but this is to get in the diagnostics. But it doesn't tell you here which up and down arrow to press, right?
But they give you like this symbol.
Yeah.
Well, we
on
have-
the left side.
Oh, we have an up and down here. This has a plus and minus there, right? So they tell us to press these two?
Yes.
Ah. Some refrigerators, they're both up and down arrows.
Oh.
Okay, who wants to try to go into that diagnostic mode for me? One of you guys that are competing. One of you guys compete. I know, Junior, you want to do it.
Junior, you want to do it so bad?
Go ahead.
Alright, now let's see.
I know you love being on YouTube.
Yeah.
We'll make a meme out of it for you.
You got
Okay, so he's gonna press them both and hold them for 10 seconds to get into the test. Once you get in, I'm also gonna have you stay there so we go through the various tests, okay?
So,
10 seconds.
Press the two, hold them for 10 seconds. 5, 4.
here we go.
Okay, all the lights come on. Just like our washer and dryer that we did the other day, all the lights come on to show you the display is working. So what we want to do now is we want to press the plus sign to deactivate it, right?
Yeah.
Okay, wait, we don't want to deactivate it, do we?
Here we go.
If we press it one time, it starts advancing through the test. If we press and hold it for 10 seconds, the board will reset itself. And that's how you get out of diagnostics, to deactivate it. So we're going to press it the first time like you did. All the LED lights up on the user interface are illuminated. So what happens, everything lights up for you and lets you know that the user interface is working. All the lights are working on the display. We're going to press the plus sign one time now. We're going to the second screen. All segments on the temperature displays are illuminated. So now you should see the windows for the fresh food and the freezer temperature display. They all light up to let you know if those LEDs are working.
Some are a lot less like.
But they are working,
Yeah,
right?
they're all working.
Okay, press the plus sign one more time, and the blank user display, no lights are illuminated. You broke it. Okay, now we press the plus sign one more time. We're gonna go into step number 28. Go ahead and press the plus sign.
There we go.
Are we in step number 28?
Yeah.
Okay, let's read what the test is to test the dispenser paddle. Okay, now here's the one thing about diagnostics. You're not going to go in someone's house and do step number 28 and test it. Step number 46 and test it. One by one, each one. What you would want to do is if we had a thermistor failure or some other component failure, we'd go through all these things here. Here's the fresh food fan, the variable capacity compressor, the condenser fan, damper, etc., etc. If we had one component, like the fresh food thermistor or the freezer thermistor failed, we'd keep hitting the plus sign till we got to step number 29.
Wow.
We're going to go through each step now just so you can demonstrate the steps and what we're supposed to do. But what we do when we go into diagnostics is we don't test every single thing. We find the test that we need, and we should read through this first to say, oh, I need to do test number 29 and 30 and 33 because one of my sensors is not working right. So I'm going to go to that test to do that. Okay?
Alright.
So let's go ahead and hit it. We're in step 28. Press the dispenser paddle, but before you press it, on, the user interface is expressed, off when you take your hand off. So when you press it on, the display should say on, and when we take it off, the display should say off.
Wow.
So that's testing the dispenser. And remember, back in the days, you had to take a meter to make that test. Or if you just press the button, you listen for the little motor going, ee, right? Or the water coming out. Okay, press the plus sign, we should go into 46. We're checking the humidity sensor. It activates automatically, so we don't need to press any buttons. We're in test for 46. If that sensor's open, it'll say OP. If it's short, it's SH. The AC heater system displays the percentage of relative humidity. The DC heater system, the heater should be on. Low, the heater should be off. Percentage relative humidity displayed when the humidity is between low and high values. Heater could be on or off. So we don't do anything. We were just looking for the displays to see what the displays are saying, right?
It says 45 and the other says 46.
Okay, so that's actually the relative humidity right now. It's about 45% humidity. Okay, the displays are telling us the humidity. Okay, let's go to the plus sign. It should be going to step 47.
47.
The dispenser pocket heater. Press the set button.
Press it.
Okay, the AC heater system, test not available. DC heater system, heater on when on and off when off. So, did it do anything when you pressed it?
Actually, no.
So, it's an AC heater system. So, in other words, when you go in that step, it automatically turns it on. If the refrigerator had a DC powered heater system, when you press that button, the heater would be on or off, and it will say on or off. Okay? So that's what it is. Go hit plus sign, go step 2. Freezer defrost heater. If you had a defrost problem in the refrigerator, evaporator's frozen up, you want to see if the heater's working. This is the freezer down here at the bottom. There's a heater down there. We're not really going to see much or hear much, but we're going to go ahead and how we're going to activate that. Press the set button, and the heater should come on. It should say on.
It says on.
Okay, so now that's supposed to energize the defrost heater. So before you have that problem, you take everything out of the customer's fridge. You go into all the diagnostics. You go to step 2. You have everything out of the freezer now. You energize to see if the heater's working. Okay, on a mechanical, you can take the defrost timer, advance into defrost to check that heater out. Okay, let's go to plus sign. Let's go to step number 3. The fresh food light on the incandescent models, press the light on and off. So
Press light on.
press on and off. Set.
Set.
Set. My apologies. There we go.
Press it off.
Pressing off.
Okay, we got bad light bulbs, right?
Yeah.
Hold on a second. What's that noise?
Okay.
Press that again.
That's
Well, nice.
They're
I got a
off.
problem in here.
He's in the wrong step.
What
Water
step
valve.
is he on?
Water valve.
Water valve.
He's on step 8. If you press the minus sign, do you go back to step 3?
same.
Like going backwards?
No, it goes 2.
Oh, well, it says step 2. Press the plus sign. We should go to step 3, right?
But it has a star.
Press the
next to
plus
3.
sign.
Press the start. Yeah.
Did it go to A3?
No, to 8. 3 has a star, man.
So 3 has a star. It says what? On incandescent models. So we probably have LED lighting in this refrigerator. There is no step 3.
Why?
What?
We
Why?
got
Different
LED
type
lights.
of lighting. Incandescent light bulbs are light bulbs you screw in.
Right.
LED lights are little light emitting diodes, are little tiny bright lights. And this particular model doesn't have incandescent. So we jumped that step. We don't have that step built even into the computer board. It has different lighting system. So it went to step 8, the water valve dispenser. So if it was hooked up to water right now, and you press that button, it would shoot water out the door.
Cool.
That's what that step is. Let's press the plus sign and go down to the next one. Well, incandescent models. Open up the freezer door. Freezer door.
Freezer door.
This would be the freezer door.
Okay, now press the set button.
Press the set button.
But it has a star as well. It says
Ah.
the same thing.
Are we in step number 9?
No, we're in step 10.
Oh, so again, we jumped the step. That's we don't have incandescent models. Okay, you gotta tell me. I can't see the
Oh,
display.
yeah, I thought that was a no, honestly.
Okay, well, I have to move this table. All right, so the auger motor is located all the way in the back there, and this is where your ice is. And this is called the auger here. And there's two fingers that rotate this inside the bucket. Okay? And as that corkscrew turns, it pushes the ice out the door. So what he's going to do is press the set button, and then the motor's running in the back. Notice that I have to press the light switch on the door because that motor's in series with the light switch. If the door's open, it's not going to run. They don't want you to throw ice all over the customer's floor. So if that motor wasn't working, you can go into that test and energize that one component. Close the door for a second. All right, before we do any more tests, something like the water dispenser or the auger motor, if the auger motor didn't work, you're pressing this button, you should be able to energize that auger. Like if you put this thing for a cube or crush ice and you press this button, the motor should be running. Why go into Diagnostics to do that test? I mean, you just press the button, right? Yes. You have a question? You went like this with your hand, that's a question. Why not just press this button if I want to test that motor? Why do I go to step 10 and turn it on and off with step 10? Why not just press the button?
Just to see whether or not the components from the inside works separate from this actual control board itself, correct? Wouldn't that be
Well, not just the control board, but if ice is not coming out, if this paddle switch is broken, would that motor run?
No.
If the motor's broken, will it run?
No.
No. So in one test, I checked just the paddle switch, and when I press it, it said on and off, right? In the other test, it sends power just to that motor. So if I wanted to check power to that motor and the motor didn't run, I go in the back there, I open it all up, and I check 110 right to that motor, but the motor's still not turning. But I'm in step 10, and it says on, and I have 110 volts to that motor. Now I know the problem is my motor. If I have to press this and do a voltage test all at the same time, I can't do all of it at once. But by using the Diagnostics, it energizes that one part so I can make that voltage test to the motor back here and see if that motor's good. And I can separate the motor from the lever on the door. Yes, Ricky?
Question. Customer called and said the ice maker is not giving you nothing but crushed ice, but the auger dog control what ice it dispenses out of the door.
The auger motor don't control that. This lever right here controls that. You see this little flap on the bottom? Y'all see that little flap on the bottom?
Yeah.
When I go like this, the flap opens wide up. So when the auger's turning, whole cubes fall out. When it's down, which is the normal position, it forces the cubes through teeth which crush the ice. So there's a solenoid back there that goes up and lifts this up, allows whole cubes to come out. Okay? So cube crush ice, if we go to step number 11, the next step, open the door. I'm going to hold this. There's a little lever on the far left. There's a little thing. You press the button. Just listen. Hit it. Set. Let it go. Okay?
It's like a centrifugal.
The piece didn't fall down. Okay, press it again. Listen for it. Pull up. So that's the part that, okay, turn the power off. So that's the cube crush ice. That solenoid is in the back here. The motor's here. The solenoid lifts this up. And that clicking noise you heard was the solenoid energized.
So it's only just a solenoid, it's only
The
one.
solenoid that pulls up, so instead of spring that drops it back down, and the spring is in here. There's a spring right
So
there.
it could be the spring or the solenoid itself.
Well, the spring will drop it back down, so we can go back to crush.
Right.
The lever's up, we're in cube. Okay?
I mean, it could be physical in here or in the solenoid.
Yes. Well, you need to know if that solenoid's doing its thing.
Yeah.
All right? So let's go to the next step, number 12. What is that?
Whoa.
Condenser.
The variable capacity condenser fan. If this unit had a fan that is variable speed, is which it says it is, you press go to step 12.
It's
When
already
you
on
press
step.
on, the fan in the back by the compressor should be running. Also, it should be running on maximum speed. You won't hear it's pretty quiet. Two things you could do. If it's in someone's house, you might be able to put your hand here and feel, I can feel the air flowing by the grill at the bottom. or you have to pull the refrigerator out and get to that fan
But I hear
and
it
check
very,
the fan.
I'm sorry, I hear it very faint.
Turn it off. Ah, turn it back on. A lot of you guys probably
I don't
can't
hear
hear
it.
it, but that fan is coming on or off.
It's on
It's on.
and
Oh, wow.
it's off.
No. You can't hear it? Come here. Come here. You can't hear it?
Put your ear next to me.
Get up on this chair. You're not crippled. Come over here. No.
No, I'm turning it off right now. Quiet.
Now turn it off.
Alright,
Turn it
it's
back on. You hear it?
Yeah.
Okay. Just because you hear it, I would rather you go down and confirm that it's running. I tell my employees, don't just assume that a part is bad, go to the part and prove it. Okay? You might try to turn that fan on and you don't hear it, you don't feel the air moving. You go and order a fan motor and you go back there and you found a mouse got stuck in there.
Oh, shoot.
So now the lady waited for you to order a part. The company paid for the fan motor. There's nothing wrong with the fan motor.
I have a question.
Go to the component, make a voltage test, do a visual inspection, confirm that the part failed. Don't just walk up, say, I know, I can hear it running. I don't hear it running. I'm gonna get a new one. Yes.
Sorry, I just wanted to know, like I see 9, 10, 11, 12, and then it jumps to 43.
It doesn't matter numerical order.
Oh, okay.
It's the way they program it.
Alright,
I
got it.
can't tell you why, but that's the way they do it. Okay, so go to the plus side. Let's go to the anti-condensation heater.
43?
What the heck is the anti-condensation heater? Where is it? Where?
It's on the door. It's the little
It's
flapper.
on the door.
The right door.
That's this door right here.
Nice.
There's a heater built into this wall right here, and it goes between the two doors. If you notice, when we open up the doors, there's nothing here separating them. So when you close the doors, this flapper is like this. When the door's closed, it gives something for this magnet to grab onto to seal the air in there. But the refrigerator gets so cold, the metal could get cold, and it would drip water because it's cold. The humidity in the air, especially if the people don't have the AC on in their house, would cause water to drip. The gaskets will turn black with mold. Water will drip down on top of the freezer door, cause rusting of the refrigerator, and all kinds of other problems. So this flapper here is removable. There's one screw on the side here. Just lifts up, quick plug, you can take it out. But there's a heater inside here. You turn the heater on and off, feel if the heater's getting warm. Okay, go ahead, close the door. Let's go to the next step. What number you want?
38.
38. So I have a VCC compressor, variable speed. Press set, the compressor's running.
Right now?
It's. Gotta stop.
There it is.
Turn it off. Okay, it's very faint, but it made a nice little buzzing sound. Compressor's running. Again, just like the fan motor, what's the compressor speed? It's gonna be on maximum high speed. Okay, it's not gonna be, you can't like raise it up and lower it and this and that. Even if you did, you wouldn't know what it's doing. But to turn it on, if the compressor wasn't running, you could do your voltage tests and stuff to it. You can do your frequency test to it and everything else. It's another test somewhere else, but you can energize just the compressor to make those tests. Okay, let's go to the next step. Fresh Food Lights, the LED model. So we got an LED model, don't we? Yeah. Press set, lights come on.
Finally.
Press set, lights go off. Does it matter about the door switch?
No.
No, door switch is not used. So if the lights didn't work when you went to someone's house, but you went into this test and the lights worked, could this switch be bad?
Yeah.
Yes. Because right now when he turns it on, that's nothing to do with this light switch.
Right.
But if we were not in diagnostics and I opened the door, light's supposed to come on because of this light switch. So we know whether it's a light switch problem or the lighting problem, the lights work. Okay, let's go to the next step.
15.
Evaporator fan, so that's 15. We open up the freezer door, the evaporator fan's located down in here. When you press set, you should hear it running.
It's on low.
Low.
Someone hear it.
Okay? So evaporator fan,
Now it's on high.
you can change speeds, low and high on this one.
How do you change it?
Just press it again.
Press set, now it's
Oh,
off.
Sets off,
Yeah,
one
yeah.
time is low, and it says low, doesn't it?
Yeah.
Press it one more time, it says high, it should be running on high speed.
Okay.
Okay? Let's go down to the next step. Damper with an inspection mirror, because the damper opens the door.
It's on 20 right now.
Go open the door.
Yeah, because LED.
Oh, the freezer LED lights, but we don't need to do those lights.
Why?
I'm not here to set the lights. Let's move all these buckets. Go put them on the stove. Oh, we gotta clean this out here, guys.
Copy. You wanna clean it?
Now, this is the newer design model. The damper's located back in here. On the older ones, there was a little cover. You take one screw off, you can see the damper. This one, you can't see the damper. So they want you to take a little mirror and stick a little mirror down here to see if it's opening or closing. But go ahead and go to step 22. And press set to turn it on.
What is it? 22.
And if you listen,
Fan.
it stopped. Press it again. That's open and closing. A damper is like a window. In all refrigerators, there are a few that are not, the freezer cools the fridge. So a damper is a little opening back there, and when we turn that on, the opening opens up, maximum, it allows the full amount of air coming in. When it gets too cold, the thermistors tell the board it's too cold, and they open and close, whether it's cold or not, to allow the airflow into the refrigerator. We can energize this to see if the motor's opening or closing, because sometimes a damper motor can go bad, and it can be stuck in a full open mode and freeze the milk and everything, or it could be stuck in a closed mode, and then we have a problem with not getting the refrigerator section cold enough. By doing this, we can see if the door's opening and closing, and that the motor on the damper's good. Okay? Let's go to the fresh food door. Step 23.
23?
Mm-hmm.
Says 36.
We jumped to 26?
36.
Oh, 36
Wow.
isn't even here.
That's all the way down. No.
There's no 36 there.
Oh, you found it.
Okay, skip 36. Let's see if we go to 23.
23?
23, fresh food door. So if we open up the door, it says open. What am I checking?
The doors. But the sensor's over there. Switch.
The light switch.
So if you try the lights and they don't work, you do go to this and then try
See
it.
if the door switch is good or bad. See if the board is seeing if the light switch is good or bad. Just because, you know, you get a reading or not, if you don't get a reading open, close, it doesn't mean the switch itself is bad. There's wires plugged in here. And these wires gotta go to the board. If they don't communicate, it's not gonna work. But if the lights work on one door and not the other door, well, hey, I wanna know if it's seeing the door opening or closing, okay? It's not a very practical test, the door light switch, but you know what? When they designed this, they said, we'll test everything from the board. And that's what they did. So we're gonna go to the next step, which would be 24, and an open and close the freezer door. I should say open and closed,
Yeah, it did.
because there's a light switch down there as well. If that light switch is bad, a lot of times it'll stop the evaporator fan motor from working. We have a unit in there that Mario was working on. Remember, was it the light switch was giving you a problem and the fan would work sometimes, sometimes not? How do you know if it's a light switch or the fan motor? You could do this test and test the light switch, yes.
Question about testing the light switch from the board. If you go to the light switch and you just check the light switch was good, and you go from, you unplug the board, unplug the wire from the board and test through the wire to the light switch and seeing that that was good. But the board is still showing that it's not working. Will
The
they
board
replace
would
the
be
board?
defective.
You replace the
Exactly.
board for just for a light
So
switch?
if you check the light, if the ladies, if it was the freezer light switch not working, guess what? Not just the light won't work, evaporator fan might not work. So would you change the main board?
Yeah.
Either that or give the lady a candle and say every time you wanna get your food, just put a candle in there. Or a flashlight. And you can pay me $300 to change the main board so the light comes on. Alright, let's go to the next step. Number 26, right?
26.
Ice maker, defrost, heater, it activates automatically. Relay is activated automatically. If CL is shown, the defrost limit switch is closed and the heater should be heating up. Is open is shown, the defrost limit switch is open, the heater's not activating. So what do you see? Open?
Closed.
Closed. Okay, so in here is an evaporator, which is your freezer evaporator. They're talking about the ice maker. So back in here, back in that component there is another small evaporator. Hold this up for me, please. More, please, so people can see a second. There's a small evaporator back in there that cools this compartment, because this is the refrigerator side. It shouldn't be freezing in here, but there's ice in this compartment. If it was a temperature refrigerator, the ice would melt. So they have a separate evaporator up there that keeps this side cold. All right? So it has to defrost just like a refrigerator does. So it has a defrost thermostat and a defrost heater on there. And on some of the older models, we had a problem with a few of those heaters failing. So you want to know if that defrost heater is working or not. So if you see CL, there is a defrost thermostat back there too that's closed, and the heater should be on and energized. Now, we want to have that compartment open so we can see if it's defrosting. We want to get back to it, okay? If it's all frozen up, we want to force defrost to try to melt some of that ice so we can get it apart and get into it. All right? So let's go to the next step. Which one are we on?
29.
Oh, the thermistor. We started off talking about thermistors, didn't we? So 29 is the fresh food thermistor. It activates automatically. It's sensed by the fresh food. If within 10 degrees of the temperature measured gauge, the thermistor location, open if open, SH for shorted. What is it displaying?
71 degrees Fahrenheit.
So right now the refrigerator is 71 degrees, and it's telling me the temperature. If it was out of range, it would either say it's an open thermistor or it's a shorted thermistor. And we'd still get that open display at the very beginning, because the board's always checking them so it knows what the temperatures are. So it will turn that unit on or off, and it'll say open or shorted even without going into diagnostics. But if we wanted to isolate them, we could check that out. So the next step is a freezer thermistor.
30.
Okay, the next one is the evaporator thermistor. The evaporator thermistor is inside the freezer where the evaporator is. There's a thermistor down